Let's find the following sum: k squared over 2 to the power k, with k going from 1 to infinity. This question is coming from Berkeley Math Competition 2017. To deal with this kind of questions, most of the time we use a series, okay? And we can get some familiar series and try to plug some values and get the result. One key idea here is that we know that the series 1 over 1 minus x is the sum of it is the sum of x to the power k, with k going from 0 to infinity. Okay, so we can get values of the series that we know by just plugging values that are in the domain of convergence of the series. So when x is 1/2, we know that the sum of 1/2 to the power k, with k going from 0 to infinity, is 2. We can check it quickly, check this one here, by just plugging x is 1/2. Here we have to do some differentiation to get the k squared. And we see here that k squared is differentiating this one twice. So we have to do a differentiation of this one here to get the first k, and after that we get k minus 1. And we plug, we multiply them to get the k squared. So that's the key idea here. So first, let's differentiate this series here. We're going to have 1 over 1 minus x squared is the sum as k goes from 1 to infinity of k times x to the power k minus 1. So here when x is 1/2, so we're going to have 1 over 1/2 squared, which is 4. Therefore, this one is 4. And the sum is going from 1 to infinity of k times 1/2 to the power k to the power 1/2 minus 1, which is 2. Okay, therefore we have this sum here, the sum of k going from 1 to infinity of k over 2 to the power k is just 2. Okay, so this is 2, and you have to divide by 2 to get this result. This is very important. Now I can differentiate this one more time to get 2 over 1 minus x cubed. So here 2 over 1 minus x cubed. On the right side, I'm gonna get k is going from 2 to infinity of k times k minus 1 times x to the power k minus 2. This is the derivative of x to the power k minus 1. Okay, the same thing when I plug x is 1/2. So I'm gonna get 1 minus 1/2, that's 1/2, that's 8. So I have 2 over 1 over 8, that's 16. So I have 16, and the sum k going from 2 to infinity of first k squared minus k squared times x to the power k minus 2 minus the sum of k times x to the power k minus 2, k going from 2 to infinity. Okay, once I plug x 1/2 here, I'm gonna have the sum k going from 2 to infinity of k squared over 2 to the power k times 1/2 minus 2 minus the sum k going from 2 to infinity of k over 2 to the power k times 1/2 to minus 2. So this is 4. So 1/2. So this is 4. So I'm going to use that one to divide both sides by 4. I'm going to get 4. The sum k going from 2 to infinity of k squared over 2 to the power k. So this is what I need. Okay? Minus this sum here. The sum of k over 2 to the power k, k going from 2 to infinity. Okay, so first I'm gonna deal with this sum here. I found that the sum of this quantity going from 1 to infinity is 2, but here I need the sum going from 2. So therefore I can write this one as, so 1k is 1, I have 1/2 plus the sum k going from 2 to infinity of k over 2 to the power k, and this is just 2 minus 1/2, that's 3 over 2. So therefore I have the sum k going from 2 to infinity of k squared over 2 to the power k minus 3 over 2. Okay, this sum I need k to be from 2 to, no, from 1. K is going from 1. Therefore, when k is 1 here, I have 1/2. So I can just add and subtract 1/2. So minus 1/2 plus 1/2, which will let k go from 1. So k from 1 to infinity of k squared over 2 to the power k minus 3 over 2. Okay, so here minus 1/2 minus 3 over 2 is, I'm gonna call this sum a. So a, so it's a minus 1/2 minus 3 over 2, that's minus 2, is 4. Therefore my sum a is just 6. Okay, remember that a is the sum that I'm looking for. So a is this one here. So this means that my sum is 6. So this is one way of finding the sum. Okay, another way is to keep multiplying and subtracting. Okay, you can or you can use some other series that I think many techniques can solve this problem, but this geometric series can help a lot. So especially this one here, 1 over 1 minus x. Here we need to know this one, how to differentiate it, and its sum and its radius of convergence. So this is the solution for this Berkeley Math competition question from 2017. The sum is 6. I didn't check with the, most of the time I check the solutions with the Wolfram Alpha, but I didn't have time to do so. So make sure that it's right. If it's not right, please let me know. Thank you very much. If you see any errors or mistakes, please let me know. Have a great day.